Alright, here we go with lesson 3, solving two-step inequalities. This is going to be a short little lesson because all of these things that we're doing right now are all of the same things we did when we were solving equations, two-step equations, multi-step equations. The only thing we need to always keep in mind is that we have to switch the direction of the inequality whenever we multiply or divide by a negative number. Other than that, all of the same algebra rules apply. So let's take a look at the first box in the top left. 160 plus 4f is less than or equal to 500. The first thing I want to do is try and isolate this variable. So in order to do that, I need to use the additive inverse property of inequality, and I will subtract 160 from both sides. That tells me 160 minus 160 is 0, leaving me with just 4f is less than or equal to 500 minus 160 is 340. The next step I want to do is divide by 4. Now remember, only when I divide or multiply by negative numbers do I have to switch the inequality. So I'm going to divide both sides by 4, leaving me with just f, because 4 over 4 equals 1. F is less than or equal to 340 divided by 4, which is 85. If I want to, I can put that on a number line. I would put 85 somewhere around the middle, 86, 87, go 84 this way, 83. I would need to put a closed dot at 85, and I want everything less than or equal to 85, so I would go this way, and that would be my solution set. Let's take a look at the one in the top right here. Negative 12 is greater than or equal to 3x plus 6. Again, I want to try to isolate my variable, so I have to use PEMDAS. And I have to go through that backwards. So the first thing I notice, I have addition, so let me do subtraction to get rid of this. Minus 6, minus 6. Negative 12 minus 6 is negative 18. Negative 18 is greater than or equal to, what's left over here is just 3x. The next thing I want to do is divide. Since I have multiplication here, I have to undo that with division. So dividing both sides by 3, 3 divided by 3 is 1, telling me I have 1x, or just x. And negative 18 divided by 3 is negative 6. Now, I divided a negative number. I did not divide by a negative number. So notice the difference here. I'm dividing by a positive number. I do not need to change the direction of the inequality. So if I wanted to put this on a number line, I could say that's negative 6, negative 7, negative 8 going that way, negative 5, negative 4, negative 3 going that way. It is greater than or equal to, so that symbol tells me that I need to put a closed dot at negative 6. And I want all of the numbers that are less than or equal to negative 6. You can read this from right to left. You can say x is less than or equal to negative 6. So numbers that are less than negative 6, those are numbers like negative 7 and negative 8, and therefore the arrow goes that way. My solution set is everything less than or equal to negative 6. Let's look at the one in the bottom left now. This one says x plus 5 divided by negative 2 is greater than 3. First thing you want to do on a question like this is make sure this is no longer a fraction. Okay, and the way I can make this no longer a fraction is to multiply everything by the reciprocal, or multiply everything here by a negative 2. And then I have to do the same on this side, multiply by a negative 2. Notice I'm using parentheses to signify multiplication. If I multiply on this side by negative 2, I end up, these negative 2's cancel out, they become a 1, and I'm left with just x plus 5. On the right hand side, I have 3 times negative 2, which is negative 6. Now I need to remember, I multiplied by a negative number, which means I need to now change the direction of my inequality symbol. Anytime we multiply or divide by a negative number, we have to change the direction of our inequality symbol. Next thing I need to do here is get this x to be by itself, so let's subtract 5 from both sides. That tells me x is less than negative 6 and negative 5 is negative 11. Again, on a number line, negative 11 would be here, negative 12, negative 13 going that way, negative 10, negative 9, negative 8 going that way. So if x is strictly less than negative 11, I would need to put an open dot at negative 11. Now I need to find everything that is less than negative 11, and that would be things like negative 12, negative 13, and other negative numbers going in that direction. Finally, we have 1 minus 2n divided by 3, and that is greater than or equal to 7. So let's use that same idea here. Since I'm dividing by 3 right now, I'm going to need to multiply both sides by 3 to get rid of this fraction. That'll make everything much easier for me. So 3 over 3, the reason I'm doing that is so they'll go away, they become a 1, and I'm left with just 1 minus 2n is greater than or equal to 7 times 3, which is 21. Now, I did not need to change the direction of my inequality because I was multiplying by a positive number. The next thing I want to do is get rid of this 1, so I would subtract 1 from both sides, leaving me with negative 2n is greater than or equal to 21 minus 1 is 20. The next thought here is to divide by negative 2 to get the n by itself. But instead, what I'm going to do is I'm going to add a 2n to both sides, and you'll see why. That tells me 0 is greater than or equal to 20 plus 2n. Now if I subtract 20 from both sides, I now have negative 20 is greater than or equal to 2n. Basically what I've just done is changed the direction of the inequality. But now I do not need to divide by a negative number. I'm left with negative 20 divided by 2, which is negative 10, is greater than or equal to n. So what I was just showing you there is there's always a way to do this where you do not have to divide by a negative number, so you don't have to remember to flip the sign, the inequality symbol, to the other direction. You can always just add that negative quantity to both sides, and that would make it positive on the other side. And then when you divide, you won't have to divide by a negative number. Okay, well that's all I have for you today. Don't worry about it. Check your understanding. Make sure you have all 4 of these examples copied down in your notes with number lines, and I will see you tomorrow in class.